Good morning, class. My name is Matovu Yiga, taking you with the fractions. Of course, some of simple operations in fractions, that is to say, addition, subtraction, and division. We shall see different ways how we can use those operations while using fractions. Then at last, if time allows us, we shall try hard that we see some applications of fractions. I know it may seem to be simple to some, but again, most times you find that many people do some simple errors that could be avoidable. First, now what is a fraction? A fraction is a rational number expressed in line notation of a stroke or b. When you find any number whereby it has a slash b, or 2 over 3, 3 over 4, 5 over 2, 7 over 8, that one seems to be a fraction. So that's why we say A over B, whereby A is a numerator and B is called a denominator. Any number on top of any fraction is called a numerator, and any number below or that is down, the down number is called a denominator. That's why we say that a rational number expressed in line notation form A over B is called a fraction. Actually, a fraction is part of a whole. When we talk of fractions, many times uh, we bring in the idea of sharing, whereby when we talk of fractions, you realize that there will be idea of sharing because a fraction comes from a whole. There is no way a fraction can exist without a whole, but a whole can exist with a fraction. That is to say that a mango can be whole mango, but a one mango when cut into halves or cut one over or into a thirds, it is becomes a fraction. That is why we say that a fraction is part of a whole. The moment you cut the mango and it becomes a half, as you see, then it becomes a fraction. That is why when you cut a mango into a half, it becomes 1 over 2, and when you cut it into 3 slices, it becomes 1 over 3, or into thirds, whereby the denominator is a third. If you share 1, it will be 1 over 3. If you share 2, if you give away 2, you will be giving out 2 thirds. Parts of a fraction in simple terms, though I have explained it the other in terms of A and B, in terms of unknown, in terms of in a broad way. But in simple terms, this one can clarify better what I was saying. This is 1 out of 4. When you see the top is the numerator, this is what I meant. And this one is the denominator. Types of fraction. Of course, we have several types of fractions, but due to the fact that we use some, I'll speak, or I'll tell you the most ones we use, or the most fractions we use. These include the proper fractions. When you see this diagram, it shows a younger child up and the older down. The younger one with the 3 and the older with 8. Whereby, as we said earlier, that when the numerator is smaller than the denominator, the 3 rather, as we said earlier, that 3 is the numerator and 8 is the denominator. So what do you realize? You will realize that the numerator up is smaller than the denominator down. Hence, when the numerator is smaller than the denominator, that fraction is a proper fraction. So proper fraction, these are fractions whereby the numerator is smaller than the denominator. For example, 1 over 3, 1 over 2, 2 out of 8, 4 out of 5, 7 out of 8, 10 out of 11, etc. They are men, 9 out of 10. You can think any of fraction whereby the numerator, that is to say the upper part, is smaller than the denominator, or whereby the denominator is larger than the denominator or bigger than the denominator. Either way can work. And then we have what we call improper fractions. Improper fraction, this is where the numerator is bigger than the denominator. Some of us, we say that these fractions are abnormal most times, because as you see that diagram, whereby the younger kid is up and the lower kid is down, it is like saying that a baby lifting up the mother. It is very awkward sometimes, and it is rare to be seen. And that's why mathematicians, or in mathematics, most times we don't use these improper fractions. Though they are there, but most times we turn them into a mixed fraction. So that's why we call them improper fractions. It is abnormal most times. This is where the numerator is bigger than the denominator. For example, 3/2, 5/4, 7/6, 9/8, 10/3, etc. 1,000/10, and so many more types of improper fractions. Then we have mixed fractions. Mixed fractions, these are fractions whereby you have a whole number and a proper fraction. The reason why we talk of a proper fraction, you cannot have, it is very rare to find a mixed fraction and an improper fraction. Since most times to get a mixed fractions, you reduce or you simplify the improper fractions. For example, 11.5, 83, 45 out of 50. You can get so many more other mixed fractions, as long as they have a whole number and a proper fractions. Others define mixed fractions as just a whole number and is like a unity fraction, but it is not necessarily mean that it should be a unity fraction. There are so many proper fractions without a unity fraction. So that is why we call it a proper fraction. For example, if you see this apple and then a half of that apple, of course, that picture brings out the ideology of, or the example of a proper fraction, and this is 1.5, as you can all see. Decimal fractions, let me add it there. These are decimals, of course. The moment you find a point in a fraction, it becomes a decimal fractions. Sometimes we may have a proper decimal fraction got from mixed fraction. That is, you can find 1.5, 0.25, 0.5, 0.125. All of them are decimal fractions. So if you have never seen decimal fraction, those can represent a decimal fraction. And that is the summary of the types of fractions. Actually, I summarized the major ones we use mostly, that is proper fractions, improper fractions, and mixed fractions. So when you see here, it shows that numerator is less than the denominator. And here, numerator is greater than the denominator. There is a whole number plus a proper fraction. What will it is? A whole number plus a proper fraction. To get a mixed fraction. Since we have identified and since we have known the types of fraction briefly, let us now go to the main objective of today, seeing operations. How do they operate? How can I add them? How can I subtract them? How can you divide them? How can you multiply them? And that is the second subtopic, addition of fractions. The first examples were addition of fractions with the same denominator. As you can see, the example is 4/6 plus 3/6. Here, you will not toil a lot. What you do, you just leave the denominator as it is and you add the numerators. I do repeat, don't add the denominator. Leave the denominator as it is. For example, it is 4 out of 6 plus 3 out of 6. That common denominator, leave it as it is, and then add the numerator. I'll give you a logic when we finish the other second part, why it is like that. I'll give you why, the reason behind that. That's why when you see, when you get these slices of chapter 2 out of 3 and you add them, you get 8 out of 3. When you get 5 out of 3 plus 2 out of 3, you will get 7 out of 3. There are very, very many examples there. You can revise a bit those examples, and you enjoy them, and you enjoy them, and you enjoy them. They are many with the different with the same denominators. You can try and you see. Then let us go. Let us get steps how to add fractions with different denominators. For example, a half plus 2/3. Procedure. First, get the LCM of the denominators. The LCM of the denominator 2 and 3 is 6. Second procedure. Multiply every fraction with the LCM of the denominators. This is what I did. A half times 6 plus 2 out of 3 times 6. Mind you, we are remaining the operation as it is, since the operation was an addition. And when you get this, you will get 2 plus 3 equaling to 5. Then they say divide the result by the LCM of the denominator. That's why we get 5 out of 6. Let us go back. I told you to give the technique. Why? We leave the other denominators constant. Actually, even these denominators will get the LCM. But all of us, we know that to get 6 and 6, the LCM will be the same. The lowest common multiple of 6 and 6, of course, it will be 6. That is why we remain that denominator constant when two different fractions, when different fractions have the same denominators. And since the LCM is the same, we don't need to toil looking for it. That's why you get that result. And when you add a fraction of the same denominator, you just add the numerators and you leave the denominator constant. For example, if you get 4 out of 6 times 6, again it will be a 4. If you get 3 out of 6 times 6, again it will be a 3. Hence, when you add 4 plus 3, you get 7. And leaving and dividing 7 by the denominator, again, it will be 7 out of 6. So it will be a wastage of time doing that when the fractions have the same denominator. Since, again, it will be the same answer when you just cram saying that, leaving the denominator constant. Let us move to subtraction with the same denominator. The same denominator, they are like similar with the addition, though the operation differs. Here there is subtraction, the other one was addition. So here, don't mess up, please. Just subtract. You say 4 out of 5 minus 2 out of 5 equals 2 out of 5. Simply subtract the numerators and leave the denominators constant. I repeat, leave the denominators as they are, and you operate on only the numerators. I think you can do others, as you can see others. Then, how to subtract fractions with different denominators? The procedure again will be similar to the one in the addition. How? You will get each fraction and multiply it by the LCM, because the first procedure or the first step, it will be getting the LCM of different denominators. And the LCM of 2 and 3 is 6. Multiply each fraction by the LCM of the denominator. When you multiply up times 6, you will get 3. And when you multiply 30 times 6, you will get 2. Then subtract the result. The result will be a 1. Divide the result by the LCM. Of course, the LCM is 6, so you'll get 1 out of 6. That is the answer. You can try. You can look for other for other questions with this similar problems, that is getting other fractions with the different denominators. But please don't forget to find the LCM. Even if fractions are 3 or 4 or 5, but if you realize that they have different denominators, I kindly request you, please first get the LCM as the first procedure, then multiply each fraction by the LCM of the denominator. Don't forget to divide all of the result by the denominator. Let us see how we can divide the fractions, how to divide the fractions. Let us see how we can share, mangoes, how we can share apples, how we can share things. First, should understand that this is the division symbol. The first fraction is called a dividend, and the second is called a divisor. So procedure: keep the first fraction the same. Keep the first fraction the same, like this one. As you see, this is 1 over 5 divided by a third. Keep the first fraction the same here. That 1 out of 5, leave it. 4 out of 5, please leave it. Make it, don't tamper with it, let it be the same. Don't change it. Change the division sign to a multiplication sign. Can change this division sign to a multiplication sign, change that division sign to a multiplication sign. Flip the second fraction. To flip is making something upside and down. Making something upside and down, that is to flip. Most people use the reciprocal. Make the reciprocal of the second fraction. If it is 1 over 3, it is 3 over 1. If it is 2 out of 3, it's reciprocal. Or its opposite is a 3 over 2. After flipping the second fraction, multiply as usual. That is, if you have 4 out of 5 times 3 out of, you get 12 out of 10. You can simplify if the fraction, if necessary. 12 out of 10 is 1 and 1 of 5. You can simplify it. Or if they didn't tell you to simplify, you can leave it there. It is according to the question. When they tell you to simplify, please simplify. Simplify, please. So those are the steps taken in division. For example, one where when we have 4 divided by 2, all of us, we know that 4 divided by 2 is 2. But how does it come? Leave the first fraction, because we all know that every whole number has a denominator of 1. So leave it. Then get the reciprocal of the second fraction, or flip the second fraction, or the second figure. The second figure is 2. If you flip it, it is 1 over 2, and when multiply, you will get a 2. If you have 2 divided by 2, in simple terms, you know that it is 1. But when you flip the second 2, it will be 2 times a half, which is a 1. 1 divided by 2, most of us know that it is a half. So it is 1 times 1 over 2. If you flip, let's say this second one, if you flip it, then it will be a half. Example 4 is that 3 out of 4 divided by 2 out of 7. Keep the first fraction, change the division into multiplication, flip this one, 7 over 2, then we get 21 out of 8. When you flip this, most times it becomes the reciprocal of the other one. We are done with division. Let us see, how can we multiply fractions? Please, when we discuss about something, you can go and try to research more about it. How do you multiply fractions? First, multiply the numerators. 2 times 3 is 6. Multiply the denominators then. 5 times 4 is 20. That is 6 out of 20. You can reduce the fraction if necessary, whereby 6 out of 20 is the same as 3 out of 10. Examples are there. 2 out of 7 times 3 out of 5 equals 6 out of 35. 3 out of 1 times 2 out of 6 equals 6 out of 6. 3 out of 2 times 5 out of 4 equals 15 out of 8. 2 out of 5 times a half, you'll get 2 out of 10, which is the same as 1 out of 5. Applications of fractions. Doctors use fractions in blood cells, whereby those blood cells, there is what we call a blood stem cell. The blood stem cell divides into other cells, like the lymph node stem cells, and so others. Doctors know that better. Then that is where we come down to red blood cells, whatever, etc. So doctors use fractions in a division of cells, and also in giving doses of medicine. They're like telling you 1 times 2. You realize that some medicine are halves, so they have to divide all those doses, hence applying fractions. Subtracting mixed numbers in real life examples, 1.5 glass of water, that is real life. When you get 3 out of 4 miles, that is real life example. Sewing, we all know these people, the tailors, they can use to measure half a centimeters to harden a half. Those fashion designers, they know how to do it better. Building lengths of boards, of course, fractions are applied. I'm going to show you down a certain building where partitions were made to track and field events. That is times where, as we measure in time, 12:30, 2:30, we apply, of course, fractions. Even in fields, like a quarter stadium, a half of the stadium. That is application of that's application of a fraction. I think you can see the partitions. You can see the partitions here. You can see in clock time how fractions wise is 12:30. In sharing, as we're sharing cakes, a quarter of the cake, I shared a quarter of the cake. That is an application of fractions. So mostly fractions help us to know how to share things to our fellows, how to share things to our people, how to share things in children and in other societies. Those are application of fractions. You can say a quarter of the month. That is to say that is 1 week. You can say quarter of an hour. Those are 15 minutes. 4 quarters in a game in football. You have ever used it. So 2 halves in football, half the court in tennis, half an hour. Those are 30 minutes. Hemisphere of the earth, half a hemisphere. All of them are applications of the fractions. Ladies and gentlemen, my first students, those are the things that I've shared with you today. Maybe meet later. Thank you very much.